Every calculator should have these buttons, the log and the ln.
Sure.
The log is actually known as the common log. We'll talk about that in a minute there. When you see the word log on the calculator, that's called the common log. What does that mean? That is actually log base 10. We'll talk about the base shortly, but I want to get them out of the way quickly. The ln on your calculator, that's called what? Natural log. That's not a piece of wood from a tree. It is actually log base e. And e is what? 2.71? So that's what the natural log, 2.71828. You know? So that's what the ln is. Every log has a base. Now, first, how do we say them? Let's see. What is section 13.2? Yep. Now, here is probably the biggest rule in the log. The log is nothing more than an exponential function. It's actually the inverse of it. And you can say if is the biggest statement. If y equals b to the x, then we can change that to x equals log y base b. So I didn't tell you what the log is, but let's say I come in and say, you know what? I think you can handle it. I have faith in you. So let's give you a quiz. What is the log of 25 base 5? Very good. We'll call that x, an answer. This works backward. It says you can go from this to this or from this to this. So since we didn't discuss what the log is, I can change it to exponential. In exponential, it says the base, I'll just put it in English, raised to the number should equal the answer. I mean, base raised to the answer, I said them backward. The base raised to the answer should equal the number. The base raised to my answer should equal the number. I'm talking about this one. What is the base here? 5. And what's the answer? X should equal the number. What's the number? 25. 5 to what power will give me 25? 2. So x will have to be 2. So when you see the log of 25 base 5, basically the question really, to what power? We need to raise the 5 to produce at 25. To what power? Five to what power is 25?
You understand that, right?
Yep.
Yeah, 2.
That's 2. Yeah, so that's what it is. I'm saying that's what that notation means when you see it. 5 to what power is 25? Another way of saying 5 to what power is 25? That's what that means. And the answer is 2. So from now on, if I come in and I go, what is log 27 base 3 equal to? Again, the question becomes what? 3 to what power
3.
is equal to 27? So x will have to be what? 3. Yep. Log 32 base 2. 2 to what power is going to equal to 32? Will have to be 5. So that's what that rule allows us to do, to go from log, which we had no idea what log is, change it to exponential, and now we can look at a problem and solve it. Where we might have a problem, if I said to you, okay, log 16 base 5. Now you got a problem.
No solution.
Oh, it has a solution.
Is it a negative?
No. Can't be, because actually more than 1. Because if it's 2, 5 squared is 25. 5 to the 1 is 5. Between 5 and 25.
So you just have to do guessing games.
Well,
I don't like that.
That's got to be 1 point something.
1 point what?
Well, it's not yet 25.
To me, I think just by looking at it, I think it looks like about 1.722706.
Yeah.
232, I think.
Your calculator was right there. How'd you do that?
Can't tell yet.
Yes, you can.
No. So that's really the answer to that. So right now we're doing the obvious ones where you can look at the number and get that. So let's focus on that. But as we change, as we grow a little bit, we're going to change that number. It's not going to be a good number. It's not going to be a match there. And we have to find other ways to do it. So we need to know there's a lot of rules about the log. There's about 7 or 8 rules about the log. And my goal for this week and next week to make sure you know them all by the time we have the test. And the first one of them, let's try this. You have a calculator? Try that. What is the log? Just push the log of negative 3. Math error. Syntax error. What's the log of negative 2? Math error. What is the log of 0? Error.
So it has to be greater than 0.
Yep. So that's rule number 1. I'm actually going to have one clean sheet of paper to write all the rules on it. It's going to be about 7 of them. So you can have a sheet in the back and just leave it. Don't write on it. And rule number 1, it says you can't take the log of a negative number or 0. You can't. And I'll explain to you why you can't take the log of a negative number or 0. Let me take you back to exponential function. Let's say 3 to the power of x. If I say, can you graph this? Log y base 3 equals to x. Well, the log function is really the inverse of this function. The inverse. Do you remember math? How do you find the inverse graphically of any function? Anyone remember how?
Like tangent and those stuff?
Nope. How do you find the inverse of any function graphically?
Does it have an end one? No.
Nope.
The inverse?
Oh, you mirror it?
We got 45 degree. You put this dotted line,
Mirror.
and you fold your paper along this dotted line, and the image you get is the answer. Yep. So the answer will look like this. That's the graph of the log function.
Oh.
So guess what? This point is what? 0, 1? Guess what this point is?
1, 0.
1, 0. Oh, I wrote on the nice clean sheet of paper.
Yes, you did.
You can't take the log of a negative number. Look at your domain. The domain is always what? X is greater than 0. There's no value to the left of that. So my domain for this function is x is greater than 0. And what is my range? My range is the y value. Where's the y value going? From where to where? From down here all the way to up there.
All real numbers.
All real numbers. Interesting. What's interesting about it? What is my
Opposite.
exponential function?
That's not infinity is 0.
The domain here is what? All real numbers for the exponential? The domain here becomes the range here. The range here becomes the domain here. Because they are the inverse of each other. That's what the inverse. X becomes y and y becomes x. That's actually how we find the inverse of a function. We interchange x and y and we solve for y. So x becomes y and y becomes x. So your domain here becomes the range here, and your range here becomes the domain here. If you don't want all that gibberish stuff, just remember that picture. The domain. I need this paper. Yep. The domain of this is x has to be greater than or equal, greater than, not equal to, greater than 0. That's why you can't take the log of a negative number or 0. That's the reason. The other rule, looking at the picture here, that's rule number 2. The log of 1, regardless what the base is, doesn't matter what the base, the log of 1 is always going to be what? 0. When x is 1, the y value is 0. Remember, 4 to the x looks a little bit sharper. 2 to the x looks a little bit flatter there. So the log function, they're all going to have that shape, either steeper or flatter. They're all going to look like this. But they're all going to pass through that just like the exponential function. So when x is 1, the log is always going to have a value of 0. Always. And rule number 3, which we already did that, said that. And what was it? That was, make sure I stick with the notation in the book. If you have y equals b to the x, you can rewrite that. That goes both ways. Log y base b equals to x. You can go back and forth between log and exponential. And these are the first 3 rules about the log. This is what I have in section 13.2. I just want to spend some time on them, do a few examples, then I'll add the other 3. Then we're done. And next class we'll show you how we can use them in real life. Now the natural log, if you see me write the natural log again, that's log base what? E, remember that. If you see me write the log with no number, that's known as the common log base what? 10. So a lot of times we just don't put the base, that means that's base 10. And if you see me ln, that's log base E. Bless you.
Is that a rule? No?
No, that's always the case. If there's no base, it's base 10. Natural log is always log base E. So if I said to you, what's the answer to this? What is log of 1,000 equal to? Notice I didn't put a base there.
And it's assumed it's 10.
Since there is no base, it's assumed to be base what? 10. And if you remember with the definition of the log, it says 10 to what power is going to equal to 1,000? X equals 3. Now, for you, this is a button on your calculator. So if you took your calculator out and you went log 1,000, it depends how fancy your calculator. Some of them you have to put the number first. Some you got to put the number last. Log 1,000 should give me 3. You can see 3? Yeah. So the calculator does the log and does the natural log. Not using the calculator, let's do this by hand first. What's the answer to this?
10 to the minus 2. Minus 2.
So you have, since there's no base, assumed to be what? So you have 10 to the power of x equals 0.01. 0.01.
1 over 100.
I like that answer. 10 to the power of x, you said that's what? 1 over 100. Which means what? 10 to the power of x equals 1 over 10 to what power? Squared. When you bring that power to the top, becomes what?
10 to the minus 2.
10 to the minus 2. So what does x have to be?
Minus 2.
Negative 2. I bet you if we go to our calculator and hit that key there, it should give me a minus 2.
I'll just use my calculator.
You get a minus 2?
Yeah.
Okay. Here's the problem. You're not gonna. I'm gonna make sure that you can't use the calculator all the time. So you have to know the rules. I know some. Oh, I don't have to memorize all the stuff. I go, okay, don't memorize it. How about this one? Log base 2, 0.825.
Oh, now we can. Yeah, that's not gonna work out.
So 2 to what power is equals 0.825? Well, let's try to be patient. 0.825 means what? 825 divided by 1,000, doesn't it?
We don't care because it's not base 10 though.
7 eighths.
Well, let's see if we can simplify it.
No? No, it's 8 7.
I gave it the wrong number.
You give us one number.
Yay, it was wrong.
You divide by 5.
Let's go 0.125 instead of 0.825.
Yeah, I thought it's 7 eighths was that, but it's 8 7.
0.125, let me change it.
20.
I'm changing that to 0.125. What is 125 divided by 100? By 1,000, I mean. 1 over 8. The 1 over 8 is what? 1 over 2 to what power? 3. So 2 to the x equals 2 to what power? Negative 3. What's x equal to? Minus 3.
Oh, okay.
How about if I do this? Log 64 base 2 equals 5x minus 3. Solve for x. Do we know what the answer to this side is?
Yeah, 6.
2 to what power is 64? 6. 2 to the 5 is 32. So that's a 6. The answer to this side is 6. 6 equals what? 5x minus 3. Can I solve it now?
Yeah.
Bring the 3 to this side. 9 equals what? 5x. What's x equal to?
9/5.
9 over 5, which is 1.8, is it?
Do you want it in a decimal form?
No, it says exact. Either one is good.
Oh.
Because that's an exact. That's not rounding. So when they say give me exact, you really could use this or use that one. Yeah.
Can you do the one then for us, Professor? Log 16 to base 5, and you were...
No, we gotta wait on that one.
Huh?
You gotta wait on that one.
We gotta wait on it.
Yep. That's coming up later, not today. We gotta leave something to tease you there. Now, what about this one? Log 1 minus log 64 base 4 equals x plus 3.
Wait, doesn't that equal one of them equal 0? Doesn't the log of 0?
I didn't even tell you what the base of this. That's fine.
Oh, yeah, log 1.
Doesn't matter.
Yeah, 0.
Rule number 2. What's the log of 1?
0.
The answer to this is 0. Log 64 base 4. 4 to what power is 64? 3. Very good. 3. 4 squared is 16.
So,
It,
but 16 times 3 is 48.
16 times 4, 4, not 3.
X
Yeah.
is -6.
So what's the answer to the left side? Negative 3 equals x plus 3. Move the 3 there. X equals negative 6.
Oh, okay. Wow, fail.
Fail.
Fail.